The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. I'm Sharon Dooley, and I'll be moderating the session today. We'd like to thank our sponsor, Dell Software. That their contribution is what makes it possible for us to give away gift cards at every one of our sessions. I want to call your attention to some upcoming SQL Saturdays. If you've never been to one of these, you should find one in your area. They are a free all-day training event, and you can learn more and find ones near you at www.sqlsaturday.com. We are the DBA virtual chapter, and we are one of many virtual chapters. And you can sign up for those that you're interested in simply by going to your profile at SQL Pass. There are also regional chapters. There's probably one in your area. You can learn about them at SQL Pass as well. They're a great opportunity to network and meet other people in your community who share your passion for SQL Server. PASS is a volunteer organization. Yes, there's a paid staff in the headquarters, but the rest of it is all run by volunteers, people who give their time to help the organization succeed. And you can join those volunteers by simply going to your PASS profile. And I assume you're all members, but if you're not, you should become a member. It's free, and it's a wonderful opportunity for a great deal of free training. And now it's my pleasure to introduce Matan Youngman. Matan has spoken for us before, and you guys are really going to like his presentation because I saw it at Summit and it's really good. He's a SQL Server MVP, a senior consultant, and a professional manager at Madeira Data Solutions. He's been working with SQL Server since 2002, and he spends his time consulting, mentoring, teaching, and speaking about SQL Server. He also co-hosts SQL Server Radio, and he's passionate about SQL Server technology and the SQL Server community. And he's done the thing that I wouldn't dare to do, and that's he's gone to Windows 10, and he was having some struggles. So bear with him. Matan, I'm going to turn it over to you, and you can show your slides, and I have to unmute you as well. So go to it.
Okay, thank you very much, Sharon. Yes, Windows 10 has been a little bit of a struggle, so one of the demos is a little bit slower than expected, but that's good because it will emphasize the point. So thanks again, Sharon, for the kind words. It's great to be here again, and welcome everyone to the data loading performance presentation. And we'll be loading some data today, as you can expect. So this presentation is actually named after a very, very famous white paper called the Data Loading Performance Guide. And if I would have arranged a poll, I suspect that almost none of you in the audience would have read it because it's a white paper. It's very long and it's full of details. And even though it's a very good white paper, it's rare to find someone that read it. So that's why I decided to turn this great white paper into a presentation. So today we'll be talking about loading data as efficient as possible into SQL Server, both from the OLTP side and from the data warehouse side. So we'll skip that. Whoops, not sure what happened here. So we skip this. And as Sharon said, I like the community a lot, and I'm also on Twitter. I work for a company called Madeira Data Solutions. We're a consulting company and a training company. We are based in Israel, but we deliver our services worldwide. And as Sharon said, I also co-host SQL Server Radio. It's a podcast I co-host with Guy Glanzer. We deliver 2 shows a month, and it's a great way to learn in a fun way while you jog, or while you're commuting to work, or while you're washing the dishes or the office, and so on and so on. Sometimes we talk to each other, sometimes we bring in guests, and we get some great feedback. So if you haven't yet, please check it out. Maybe you like it. So our agenda for today: we load data, we'll then load it faster and faster and faster. It's that simple. And without further ado, I'd like you to meet the #1 enemy of data loading in SQL Server. So what we have here, we have a database called data loading, and I'll create a table called load me fast. And what we'll do is that we will load 100,000 rows into this table in a loop. And now we'll have to wait for this demo to finish, and this is actually the demo that is slightly slower than usual. So usually inserting this 100,000 rows takes 20 seconds. So we'll see whether it takes 20 seconds or not, but the point is that loading 100,000 rows into SQL Server, and it took 24 seconds, everything's okay, we understand it's good. So still loading 100,000 rows in 24 seconds into SQL Server, it's pretty lousy, right? It's not very efficient. So let's see how we can solve this problem. So we'll truncate the table, and we'll do the same thing again, but we will use a transaction. We'll use begin tran and commit. And once we do that, it takes only 1 second. So what is the difference? What is the difference? You may say we worked row by row. So this is almost accurate, but not 100% accurate. So the problem is, we can see that here. This is our first load into SQL Server, and you can see what we see here is in perf mode, the log flashes per second. So here to the right, we can see that we have lots of log flashes per second into SQL Server. Log by log meaning the transaction log. And if we look here at the left, we can see that we have only few log flashes per second. So what is the difference? The difference is that if we load data in a loop into SQL Server, like in the first loop, each and every insert inside the loop, each and every one of the 100,000 rows opened an implicit transaction. And once we open a transaction in SQL Server, in order to commit it, we have it has to be durable on disk before it can be considered as committed. So basically, we go 100,000 times to disk, and disk is traditionally the slowest part in every computer system and every database system. When you use a transaction, we say to SQL Server, okay, I'm handling the transaction, you just load the data. And then we go to disks much less times than in the previous loop. And now we can see that the #1 enemy of data loaded in SQL Server is the transaction log. And along the presentation, we will look at ways to minimize the amount of data that we write to the transaction log. So if you take only one thing from this presentation, is that the transaction log is your enemy when loading data. And you have to figure out how to write as much less data into the transaction log. Another thing that we can do starting SQL Server 2014 in order to do about the same thing is to use something that is called delayed durability. And what delayed durability means is that when we load data to SQL Server the regular way, as we said, that the data has to be durable on disk before committing the transaction. When we use delayed durability, we write to a buffer in memory, and this buffer is flashed to disk asynchronously. So when we write to this buffer, we can continue working. The application sees the transaction as committed, and it can continue to work. So it will make data loading much faster, but there is a risk that we will lose data. If the system fails, if the server is restarted, we have a slight chance of losing data. So you have to figure out which tables fit to this scenario and which tables are not. Let's say you have a big log table that you just write and look at once in a few months. It can be relevant, but if you have a table with bank transactions, it won't be such a good idea to work with it. So the buffer is automatically flashed to disk every few milliseconds. So even if you will lose data, you won't lose much data, but still this is some data loss. So let's see that. We'll alter the data loading database and set delayed durability to false. This means that each and every transaction is delayed durable, and we will truncate the table and load data the old way, and it will take about 2 or 3 seconds. And when we look at perform again, we can see this spike, and then we go down again. So this is another way to mitigate the transaction log problem, but again, watch out for data loss. So let's get back to the slides and talk about our real agenda. So the first item was to meet the #1 enemy of data loading in SQL Server, which is the transaction log. We'll talk about clustered index key selection, bulk load, and minimal logging. Those are not the same thing, so we will talk about the differences, and we will talk about advanced optimization in order to load our data faster into SQL Server. So let's start with clustered index key selection. Traditionally, our clustered index key selection is as follows. We want our clustered index key to be narrow, so that the clustered index and the non-clustered indexes which point to it, which will be as slim as possible. We want it to be static, so that we don't have to update it and generate fragmentation, and also so we don't have to update the non-clustered indexes. And we want it to be ever increasing, so that we don't have to generate page splits and fragmentation when we insert data into the clustered index. And for the vast majority of systems, something like more than 90%, I would assume, of the systems, this will be a very good choice. You can read some articles by Kimberly Tripp about the clustered index debate, and she talks about all of those attributes of the classic clustered index key selection. So for the vast majority of systems, this will be very good. But from a certain scale, this is not good enough. And here's why. If we look at the structure of the index, if we work with an ever-increasing key, all of the rows will go to the end of the index, and to be more accurate, to the last page of the index. Let's say we have an identity column. All of the rows will get to the last page each and every time. And when we have many sessions, all of those sessions try to write the data to this last page. And when we insert data into a page in SQL Server, we have to require something that is called a latch. A latch is a lightweight synchronization object for in-memory objects, and it's there to protect the data structures of the data pages in memory. So when I insert data, no one can change the page because it will be inconsistent. So what happens is that when I want to insert data into a page, I basically lock the page, and then I finish, and then another session comes in, and then another session comes in, but only one session can load data into that page at the same time. And let's see, before talking about the solutions, let's see the problem. So we have a table called user entries regular with identity, and we have an identity column as the clustered index key. And we'll truncate the table and use a stored procedure in order to insert data into the table. And now from an external application called SQL Query Stress, we will execute the stored procedure from 10 threads in parallel, and we'll hit go. And now we will look at a DMV called SysDM OS wait stats, which shows for each and every wait in SQL Server how many tasks were waiting on this wait type. And what we can see is that we have lots of latches, lots of latch waits. Look at the waiting tasks count, it's at 37K, and now it's in 38K, and so on and so on. So we see that we have lots of latch waits. Let's see if it's finished. Not yet, and again, it's only 100,000 rows that are loaded into SQL Server, and it takes more than 50 seconds already. And this is because the latch problem that we just saw. So we let it finish, and for now, start talking about the solutions. So the first solution is InMemory OLTP that was introduced in SQL Server 2014, and this is a new engine that was developed by Microsoft, and it uses latch-free data structures, and actually they are called log-free data structures, but they are used by SQL Server in order to insert data into pages without using any latches. So this is started in SQL Server 2014, and let's see how it works. And we finished in almost 90 seconds. So we'll go to our script again, and actually we'll clear our wait stats before that, and we go to our script again, and now we see that we have an in-memory table with memory optimized equals on, and our primary key is a non-clustered hash index. This is how in-memory OLTP works. It has hash indexes and range indexes. So we'll use hash index, and we'll delete the table and alter the stored procedure to insert the data into that table. And from another window, we'll execute the stored procedure again from 10 threads. And when we look at our latch waits, we'll see that we don't have any latch waits at all while inserting data. And that's because the Hackathon engine, the in-memory OLTP engine, doesn't use latches at all when inserting data into SQL Server pages. And it takes, let's see, 26 seconds. So we cut about 50% of our insert time And again, thanks to Windows 10, it's slightly slower than expected. It usually takes about 15 seconds. So this is one option. But the problem is that InMemory OLTP, for one, requires Enterprise Edition, and it takes some time to convert your tables on your application to work with InMemory OLTP. And it has some limitations, especially in SQL Server 2014. It's much better in SQL Server 2016, but in any case, it's not completely easy to start working with. So let's talk about other solutions. And the next solution is to use a non-sequential key. And by non-sequential key, I mean that we won't use an identity that inserts data to the last page of the index each time, but we'll actually use a GUID in order to insert data into SQL Server. And a GUID means that each and every time we get a random key, and this means that we will insert data to the whole table and all across the index and not only at the end of it. And this sounds like a very bad idea, right? Because it generates lots of fragmentation. So it's generally true, but specifically for the purpose of loading data fast into SQL Server, this is actually good. And let's see that. So again, we'll go to our script, and we will use a unique an ID with a unique identifier with a default of new ID. This means that we get a new random key, and we will truncate the table and alter the stored procedure to insert data into that table. And again, execute the stored procedure from 10 threads. And we'll wait a little bit. It should take between 25 to 35 seconds, depending on the Windows 10 god. Okay, 35 seconds. And now let's look at the amount of fragmentation that we have in the table. And not surprisingly, we have almost 100% of fragmentation in the table. And that's pretty much by design, because we wanted to insert data all over the table and not only at the end of the index. But maybe there is something that we can do. What would happen if we build the index with a fill factor of 10%? And this means that when I build the index, I fill only 10% of the page and leave 90% of the page empty for new rows to come in. And this way I basically bucketize the table, and each and every row will go to its designated bucket. So this means the table is bigger, but inserts will be faster, and we won't have fragmentation. So let's check that. We'll execute the stored procedure again from 10 threads. And while it's running, let's see if you have any fragmentation in the table right now. And we can see that even though we load data into unique GUID column, we don't have any fragmentation at all. And let's see if it finishes. 36 seconds, almost the same as in the previous situation. So to be fair, as the table will get bigger, and you will have more fragmentation. But then again, you can always rebuild the table again with a fill factor of 10%. You have to be careful with this method. It's not fit for each and every table, but for some tables, it will make your data loading processes just fly. So what we saw right now is that we bucketized the table, and if we have many pages in the table, some rows will go here and here, and some rows will go here and here, and some rows here, and so on and so on. Our last solution is called hash partitioning, and it uses SQL Server partitioning in order to split the table into a few separate physical parts and actually a few separate clustered indexes. So if we have a few partitions, the first row will go here, the second row will go here, and then here, and then here, and so on and so on. And that way, we spread the load among a few separate physical clustered indexes and allow much more rows to come in at any specific time. So before that, we had this situation where we insert data to the last page of the index, and now we'll have this situation where we insert the rows into the end of this index and into the end of this index, and so on and so on. This is just a demonstration for two indexes, for two physical partitions, but we can have 10 partitions or 20 partitions, and so on and so on. So how does it look? What we have to do is first create a partition function with 10 ranges in this case, and a partition scheme that will map the table to the that will map the values to file groups. And the table will sit on top of this partition scheme. We have, and in the table, we have our identity column, and we have a hash ID column, which is cast of the ID, the identity column, modulo 10. And this means that we have some kind of round robin algorithm, and this makes the cyclic operation. The first one will go to the first partition, the second one to the next partition, and so on and so on. And let's see how it works. We'll add the procedure to work with this table, and execute again from 10 friends. And while it's executing, you may ask how to query data from this table. So what we'll have to do, let's say we want to query the table for ID equals 5, and we want to achieve partition elimination, which is a very important practice in SQL Server partitioning. We don't want to read data from all of the partitions, only from the relevant partition. So what we'll do, instead of select star from the table where ID equals 5, we will also need to add the function where hash ID equals cast 5 modulo 10, just as we have here in the table definition. So let's see if it finished. 50 seconds. So this is still better than our original situation. So this finishes the part of the presentation which is more relevant to OLTP stuff. This is relevant also to data warehouse stuff, but this is the end of this part. And are there any questions up till now, Sharon? Okay, seems like there aren't any, so let's continue. And let's talk about the optimal data load.
Wait, Matan, I've got one. I just forgot to unmute myself.
Okay.
Are there ways to increase the loading of tables with lob data types?
Great question. So first thing, log data types need to be written to the log also. So you need to watch out from the transaction log. There is also the concept of whether the log data types are stored inside the table or are external to the table. If you keep the log data inside the table, it will make your cluster index bigger. So in some situations, it will be better to make sure that your log data is stored outside the table. Other than that, I don't know about some best practices by heart. I can check that, and I will be happy to write about it in my blog. That's a great question.
In what types of workload should we use identity?
In most workloads. as I said, for the vast majority of systems, this will be the best choice because your cluster index will be narrow and will be ever increasing, and you will generate the least amount of fragmentation. The fragmentation also means that you have page splits, and when you have a page splits, you have to copy 50% of the page to another part of the table on disk. So this means some movement of data, and this is expensive. You will start getting some problems with scalability when you load data from many sessions. So if you have a single process that loads data into the table, most likely and the identity will be the better choice. If you load data from, let's say, 100 processes at once, let's say you have an application or mobile application where users connect to the database and load data, most likely identity won't be scalable enough, and you need to look at the solutions that we just saw.
And the last question is, what about loading into heaps?
So we will talk about it in the next one or two slides. But for a spoiler, heaps are generally the fastest way to load data. So this is a great question also.
Okay, so you can go ahead.
Cool. So of course you need to take into account not only loading the data but also querying it. But if we talk just about loading data, heaps are a very good choice. Okay, so for the data warehouse part of our presentation, the optimal data loading ingredients. So those are minimal logging, bulk load, table layout, CPU utilization, network configuration, and disk configuration. And we will talk about all of those ingredients for the rest of the session. So minimal logging. What minimal logging means is that only allocations are logged. And this means that instead of writing each and every row that we insert into the page in SQL Server, we just say this page is allocated or this extent is allocated, and so on and so on. We don't write the whole data of the page to the transaction log. We just say that this page and this extent are all already allocated. And this means that we write much less data into the enemy, the transaction log. It's supported only in recovery models, simple or bulk logged. If you work with full recovery model, it won't help you. All of the data will be written to the transaction log, and it has some supported operations: select into, create and rebuild index, and bulk load operations when they are done right. And we will see what right means in just a few minutes. Bulk load means that it's actually a continuous stream of rows. It's not a table, it's not in a table form, it's a stream of rows that we send from the application to SQL Server. And it works on top, directly on top of the tabular data stream, which is a low-level protocol which SQL Server uses to talk to external applications. And this means that we don't have to unpack the rows into a table all the time. So we save lots of packing and unpacking and lots of network activity, and because of saving this, the data loading is much faster. And we save lots of sync hack between the applications in SQL Server, because SQL Server knows this is a stream of rows and just loads that into the table into SQL Server. The supported methods for backloading data into SQL Server are BCP. It's an external application that can be used from both the same machine as SQL Server and external computers. Bulk insert, which is inside the SQL Server process, and it means that it's much faster, but it can only run from inside the machine that SQL Server runs. It can't be run from the network. SSIS has two methods: SQL Server destinations, which is kind of like bulk insert. You can use that only if SSIS sits on the same machine as SQL Server, and OLTP destinations, which is the parallel to BCP, which means that you can use it from external computers. And the scenario for that is that if we want to load lots of data from many external computers into SQL Server, we can do that in parallel for many machines using either OLTP destination or BCP. And another supported method is insert select for bulk load operations from inside SQL Server, obviously, and bulk API. If you have an external application that you've written, you can use bulk API in C#, .NET, whatever. You can use bulk API to load the data in a bulk load fashion into SQL Server. Now, indexing tactics. We have two options: to work with clustered indexes and to work with heaps. Let's start with heaps. So our option is to load to a heap and build our indexes later. And let's start, before talking about these bullet points, let's start loading some data. We don't need those ones anymore, and we don't need this demo anymore. Okay, so the way to load data using BCP, let me just truncate the table and make sure our recovery model is simple, and let's start loading data the naive way. I have an external file with 5 million rows that I will be loading into SQL Server, and what we have here is just a table with no clustered indexes. I made sure to drop the clustered index. So what we're doing is loading data into a heap, and paste that and let it fly. And we can see the rows starting to flow into SQL Server. But if we go back to perfmon, we can see over here that we have some, if you remember, we look at the log flashes per second counter, and we can see that we have some log flashes. And this means that we don't work in a minimal logging fashion. This means that we write some data to the transaction log, and this means that our data loading process is slower than it could be. And we've loaded 3 million rows from our 5 million, and we will wait a few more seconds for it to finish. and then we will see what our pace was. And 4 million. And we can see that our pace was about 70,000 rows per second loaded into the table. Let's see how we can make it faster. So we'll trunc the table again. And now, instead of loading the naive way, we will use something that's called the tab lock hint. And what a tab lock hint means is that we lock the table, obviously, and when locking the table, SQL Server can use minimal login while using the bulk load operation. Now, this also allows, even though we lock the table, this allows other processes which use the tab lock hint in bulk load mode, allows other processes to load data at the same time. So this means that we can load from many external sessions into SQL Server in parallel. It uses a special lock called a BU lock, a bulk update lock, and this means that regular sessions can't load data or read data from the table, but sessions that use the tab lock hint in the bulk load fashion can load the data in parallel. So let's stop talking and start loading. And we can see that data starts to flow faster into the table, and now we can see that we don't have any log flashes at all into the table. And this means that we write much less data to the transaction log, and the data flows much faster into the table. So let's see. And as you can see, from 70,000 rows per second, we're at more than 200,000 rows per second. And again, the transaction log is your enemy when loading data into SQL Server. Another thing you can do when loading data is to use the network packet size. The default network packet size, if we look here, is 4K. And this means that if you remember, we send a stream of rows into SQL Server, but this stream of rows will be cut to 4K chunks. What you can do is to increase the network packet size to, let's say, 32K, and in many situations, especially when you load data from external processes to SQL Server. Let me just trunc the table before that. This means that your stream of rows won't be cut to 4K chunks, but to 32K chunks, and in many situations, it will be faster. Now we load data from my laptop, and it uses a virtual network card, the loopback card, so it may help and may not help. But let's finish. Let's let it finish and see. And it's actually slightly slower, but it's within the range that it's pretty much neglected. So if you load data from external machines, you will see the benefit of it. So as we saw, we want to use the tab lock hint, and the pros are that generally, as I said earlier, this is the fastest way to load data into SQL Server, because you don't have an index structure to maintain, and you can load data very efficiently from many external connections. And as I said, parallel loading works very well. The cons are that it doesn't allow reading during the loads. So you can load data from many external processes, but you can't read the data. And building indexes takes time. So if we load data of, let's say, 1 billion rows, it will take some time to build the indexes and start querying the table. So you have to take that into account. Maybe it's good for you, maybe not. But generally speaking, indexes takes time, but maybe not as much as you. Today's modern systems work very well, and even a 1 billion rows table takes time to build the indexes, but not as much as it used to take. Okay, from heaps we go to clustered indexes, and our next option is to load to a cluster table. And when we load to a cluster table, we do not want to use the tab lock, because when we use tab lock, all of the table is blocked, and also from for other loading processes. So we do not want to use the tab lock. We do want to use something that is called trace flag 610. If we don't use trace flag 610, we won't be able to load data in a minimal login fashion into the table. And let's see that. We'll clear the screen here, and we'll make sure that the trace flag is off for start, and truncate the table and create a clustered index on top of it. And load data the naive way into the table. And let's look at perf1 again. And what we can see is that we actually get minimal login on the table, and that's probably because the table is empty. So we let the process finish. But before it finishes, we're stuck. And the reason that we're stuck is that SQL Server has, because we have a clustered index, SQL Server has to sort the data, the whole 5 million rows, and most likely it will have to sort it on disk in TempDB, and it takes some time. And this is because we have a clustered index. So we have a way to mitigate that, and we'll see that in just a few seconds. And we let it finish. Yes, sorting takes time. So while it sorts, let's look at the next part of the demo. Our next part is to enable trace flag 610, and as I said, when the table is empty, you don't have to use trace flag 610, but once it's not empty, we have to use it. So it finished, and the pace is not really good. It's just 47K rows per second. So we'll enable trace flag 610, and we'll skip a little bit, and we'll get to the order hint. And what the order hint means is that if I know that my external files are sorted by some column, and I will want it to be sorted for the column that is the clustered index, in my case, the transaction ID, I can use the order hint and tell SQL Server don't sort the data. And if we truncate the table again and load the data using the order hint, and just make sure we have the trace flag turned on, and paste and let it run. And let's start with perf1. And we can see that we don't have any log flashes to the transaction log. And when it gets to 5 million rows, we will see that it doesn't sort the rows and just loads them into SQL Server. $4 million and 5, 4, 3, 2, 1, and 120,000 rows. So we both load data in a bulk load, minimal loading, and we don't have to sort the rows. And this way, the rows get very, very fast into SQL Server, but again, not as fast as heaps. It's fast for clustered indexes. It's still relatively slow for heaps, but again, we have to balance that with the option to query the data afterwards, and so on and so on. So other things to consider if you load data from many external files, use non-overlapping ranges. What does that mean? If you have, let's say you want to load 20 million rows into the table, you can separate the 20 million rows into 5 million rows files, and those files, each and every file will hold non-overlapping rows of the table. So the first one will hold rows of 1 to 5 million, the next one 5 million to 10 million, and so on and so on. And that way you can load data in parallel into the table. As we saw, use the order hint, and this loading data into the cluster table allows reading from the table while we're loading from it, as opposed to loading to a heap. Now, non-clustered index changes may not be minimally logged depending on the execution plan SQL Server chooses for the data loading process. Okay, batch size. You have the option to, when loading the data, to say the size of the batch that will be loaded. And using batch size, you can do a few things. Each batch is a separate transaction, and the main usages are to prevent TempDB spills when loading to the index table. If you can't use the order hint, it may be beneficial to use the batch size, because if you don't specify batch size, SQL Server doesn't know how many rows will be in each and every batch, and when it has to sort the rows, it has to spill data into TempDB and to disk, and the sorting will be slower. So using batch size, you will still have to sort, and it will be slow, but maybe not as slow as if you wouldn't use the batch size. Another thing that batch size is used is to prevent log escalation, because each and every transaction is, let's say, 2,000 rows, and we prevent processes from locking the whole table. And if we prevent log escalation, of course, we allow reading from the loaded table. Now let's talk about loading a partition table. Let's say I want to do that. One option I have is to, let's say I have a table with 12 partitions, and I want to load data to all of the partitions. What I can do is to switch out switch out the partitions, bulk log into each and every partition separately, and then switch in. And that way I make sure that I load data in the fastest way, because each and every partition is a separate table when they are switched out. And I make sure that I don't have any log escalation and any other options for processes and partitions to interfere with each other. Now, do you remember the ever-increasing key problem? This is one way that we can use to mitigate that problem. Let's say we have a very big table with an identity column. What we can do is to take our hot partition, our new partition, let's say we have a daily partition. We can take out the current partition and load data only to this, drop the clustered index from this partition, load data to the table as a heap, then build the clustered index and switch in that partition. And this means that we load the data much faster into this specific partition from many external processes, and then we can switch into the regular table and read from that partition. Now, of course, it doesn't fit to each and every scenario, but for this specific scenario, this will make your loading processes much faster. Other options is that let's say we have 12 partitions. We will use 12 external processes to load data to the table. Of course, each and every process will load data to one partition. And of course, we want to make sure that the loaded files are partitioned correctly according to our partition function. Insert select versus select into. Both of those operations allow minimal login. Both use bulk load optimizations, and the select part is parallel in both. So if you're used to using insert select or select into, both of them are good for those things. But starting SQL Server 2014, the insert part is parallel in select into, but not in insert select. I'm not really sure why. Not sure if anyone knows other than the dev team in Microsoft, but in some situations, select into can be faster than insert select because of this, because the insert part is parallel only in select into. So take that into account when you consider whether to use that one or that one. Now let's talk about large updates and delete. Let's say you have 1 billion row table and you want to delete half of it, 500 million. So how can you do that as fast as possible? So you can use bulk load and minimal load operations in order to do that. So let's say we have a partition table, January, February, March, and April, and so on. So what we can do is first of all, take only the needed rows, meaning the rows that we want to keep after the delete finishes. We take care of that using insert select or select into an external table. And this means that it will be minimally logged and bulk load. We switch out the current partition, and this means that all of the rows in this partition will be deleted, of course, and then we switch in the table with the rows that are relevant to us. And this means that we just deleted 500 million rows with no logging at all, using only bulk load and minimal load operations. For updates, it's slightly more complicated, but not very complicated. Again, let's say we want to update 500 million rows. So we take the updated rows out using bulk load. We take all of the rows out using switch out. We switch the partition out. We merge between the updated rows and the non-updated rows to a new partition, and then switch in. And again, we performed a very, very big and complex operation using only bulk load operations and the minimally loaded operations. Now, CPU utilization. What do I mean by that? What I mean is that, generally speaking, for most operations, let's say you have many external files or many external processes that load data into SQL Server. Generally speaking, we want each and every such external file to use one core. And we map one core and one process to, let's say, a partition in the table or a range in the table. And generally speaking, when using this method, mapping files or processes to cores, you will get very good performance. you will have to watch out for something that is called SOS scheduler yield. And what is SOS scheduler yield? Each and every process that performs some operation in SQL Server has to get something that is called a worker from SQL Server, and this worker is mapped to CPU. And when many processes are mapped to the same CPU, this means that only one process can work on each and every time. So let's say we have 16 cores. We don't want 15 of the processes to be mapped to the same CPU and one process to be mapped to other CPU. Generally speaking, we want one process to process one to be mapped to CPU one, and so on and so on. So if you see lots of SOS scheduler yield waits, you can see that in sysdm exec requests. This means that the processes are waiting for the same CPU. So you need to watch out, and you may need to control markstop. If you have queries that load data, you don't want one query to take all of the CPUs. So you may want to limit that to max.1 or max.4 or so on and so on. PFS contention. And I apologize, we will, it will take us a few more minutes. We'll be slightly off time. So what does PFS contention means? PFS means page free space. And when loading data, a SQL Server has to search for pages that have free space in order to get the new data that we load into the table. So a PFS is something that looks like a bitmap, and it indicates which pages have free space for data to come in. Now the problem is that SQL Server stores one PFS bitmap for 4 GB in a file. So if you have only one file in your file group and you load data from many external processes, this PFS map can be a bottleneck. So the solution is actually pretty simple. Just add more files to the file group, and you will solve that. So if you load data from an external processes, then just make sure that you have a few files in the file group, and you will solve this problem. Network. And again, we are at the advanced optimizations phase of the presentation. So one advanced optimization that you can do is to use jumbo frames, and this means that your TCP/IP packets will be larger. And again, as a network packet size that we talked about earlier, this means that when you load data in a biplot fashion, your stream of rows will always be cut, but the question is, will it be cut to chunks of what size? So using jumbo frames, you will have less slices of your stream of rows. So you can do that in your servers. It's at the network card level. Talk to your network guys. Another thing, we already talked about it, larger network packet size, and it prevents the stream from being broken into smaller pieces. Disk layout. So when loading data, and this is actually a best practice for each and every database, not only databases that need lots of data to be loaded in a small amount of time. Pre-size your data in log files, and it has a few reasons. The first reason is fragmentation. If we have a small file and it has to grow all the time, so this file will actually be cut to a few separate physical parts on disk, and it generates fragmentation. The bigger problem is that when we increase the size of files, SQL Server has to go all over the file, and for each and every byte of the file, mark 0. It has to zero the file. And that's because of some security reasons. And this operation is very, very slow because SQL Server has to go over each and every byte and mark 0. This is very slow. So you can kind of mitigate that if you enable something that is called instant file initialization, but it's relevant only for data files. It's not relevant for log files. Even if you enable instant file initialization, when your log file grows, SQL Server will still need to zero the data. So if you start loading to 1 billion rows table and your log file has to grow all the time, your data loading process will be much slower than it can. So make sure to precise your data and log files and to enable instant file initialization, and have enough data files to reduce PFS contention and to benefit from some IO subsystem optimizations. Other factors for disk layout is to use modern hardware and proper array. Don't use USB sticks to hold your big tables, and make sure your interface is fast enough. And what do I mean by interface? Let's say you have your server and you have your SAN array at the other side of the building, let's say. So you need some pipe to connect between your server and your SAN array. And even if your SAN array holds flash drives and SSD drives that are very, very fast, if your pipe is not big enough, then it won't help. So you have a few options for interfaces, and you just need to make sure that this interface is fast enough. Some interfaces are iSCSI, and I actually forgot the names of the other ones right now, but the guys at Brentozo Unlimited have a very good poster about the name of the interface and how big it is, how much data can it move in a single second. And don't neglect outer file storage. If you have to read a big external file from an external computer, you also need to make sure that this file is stored on a reliable and a fast disk as well. So if you want your data loading process to work well, don't put your external file with, let's say, 50 million rows on a USB stick. Again, it will hurt your data loading performance. So to summarize, transaction log is not your friend, it's actually your enemy. So you want to write as much less data as possible to the transaction log because it sits on this disk, and the disk is the slowest part in every computer system, and you don't like that. Think about your keys. Use minimal logging and bulk logged, and again, you have some terms of when bulk log works and when minimal logging works, so you want to leverage those two options, and CPU, network, and IO matter. And thank you very much for listening.
Thank you, Matan. I don't see any questions, but they may start coming. We'll give them a couple minutes, but
Sure.
I think that they are probably overwhelmed with all of this stuff. You've given them so much information. While we wait to see if we get any questions, let me announce our raffle winner. It is Peter Devine, petergdevine@gmail.com. And this is our last session in 2015. I hope you all have a great holiday season and a prosperous new year, and we'll see you in January. And so there aren't any questions, Matan, so thank you again.
Thank you,
And
Sharon.
I'll stop the recording and end the meeting. Whoops, there's a question.
Oh.
Oh, there. Okay. Great. Is the session recorded? Yes, yes. You all know that. Great presentation. Fabulous presentation. Will the presentation material be available to download? Please send it to me, Matan. I'll post it. Thank you so much. Awesome. Great session. Thank you. So, the
Thank you very much, everyone.
attendees had a good time. Thanks.
Thank you.